Saving CF190207 and I'm going to talk about the introduction. Next is stadium overview. A stadium is a venue for outdoor sports, concerts, or other event that consists of a field or stage surrounded by a sheer structures. So the stadium was constructed as a badminton stadium with 4 courts, and the rectangular shaped stadium with a triangle roof was chosen for this project. After that is design concept and erection methodology. Steel erection entails locating, aligning, and attaching the components on prepared foundation to form a complete frame. As the initial step, construct 2 brace-bay side columns with bracing beams. After that, assemble the adjacent grade rafter. Finally, install wall, passes, downspouts, and gutter. As for the choice of truss design and engineering judgment, first type of truss that will be used in this inquiry is the pad truss. And then the design is streamlined and more economical since the steel in the diagonal members may be reduced. After that, the total height of the truss suggested in this project is 1.793 meters, with a total span length of 19 meters and a slope of 10.96 degrees. And S275 is the steel grade that will be utilized for the truss member.
My name is Alicia. Now I'm going to show the design overview for this project. Our project is designed by using SketchUp and AutoCAD. So figure below shows the layout designed by SketchUp. This layout is designed by AutoCAD. Next is about the truss. A truss is a load-bearing structure composed of straight components that form a triangle. Figure below shows the truss that we used in our project.
So far, I introduced myself, my name is Cho In Yun, and I would like to continue with the step 4 analysis. So we have analyzed for the beam maximum moment, beam axial force, and shear force. So from the result that we can conclude that the maximum shear force is 56.96 kN, and the maximum bending moment is 132.02 kp/inch, which equal to 14.92 kN/meter. That's all for me. Thank you.
My name is Simin Losna. I want to present chapter 4 design, tension, and compression touch member. First, we make a table. This table is labeled out the touch member, internal force, and acting in tension and compression. From this table, we know that 2 top cord and 3 bottom cord and 5 internal cord. Then we do in calculation, and there are different internal force and 5 tension and 5 compression. The figure above the table is show that what is our design shape and what is the reaction flow. And then we continue to calculation part is the internal cord. First, we need to take the maximum design force, and then after we try to assume the sign RHS, and then we label out the properties. Next, we do the classification of the cross section. After that, we do the braking resident in plane and out plane. So that after determining our braking resident in plane is larger than NBRD is larger than NED, then this design should be okay because the braking resident is passed. After that, we do the outplane braking residence, and we find the LCR first, and then we do the find the lambda first, and we find the angle and S first. After we find it all, then we do the NBRD. NBRD if larger than NED, that should be okay. That means the braking residence of this selected this size should be okay. Okay. This table is the summary about our calculation. 2 top cord and 3 bottom cord and 5 internal cord, and NED are the different, and SCRD are the same in top cord and bottom cord internal cord because they take the lengths are the same. NBRD also the in plane or plane in top cord are the same because they take the LCR are the same.
I want to present a design of connection. Design of connection is the truss member cross section for top, bottom, and internal chop. In this study is rectangular hollow section, hence the type of connection chosen to be designed is wire connection. Hollow sections are typically connected by wiring. Small truss which can be transported from the fabrication factory to the site can be entirely wet. Wire connection with truss is 8mm fluid web, and the design shear strength of the web total is 223 Newton per millimeter square. For the design resistance of the web per web, the total is 1.25 kN per meter. For the total resistance of web is 1.25 times 45 count from the request frame, and the total is 56.25 kN is more than 11.606 kN. For the balance the weight on its size, the length is C meter and the request length is C meter by 16 is F2 S is 22 millimeter, set by 25 millimeter, and for the request length is 2.85 is count from the other size length and plus 16 millimeter is F2S. The total is 18.85 millimeter, set 20 millimeter. This is the detailing of the truss, detailing of the connection between members. That's all for my present. Thank you.
Now I will present about the conclusion. The analysis and design of steel truss stadium using manual calculation, as well as the design of analysis of steel truss stadium utilizing STEPPRO software, were exported in this research. This project has a width of 21 meters, a length of 41 meters, and a height of 7.5 meters. The design of steel truss using equation for solving is complex and time-consuming. Computer software programs are used to design the analysis this type of truss. This program take the input of the truss design and perform the calculation easily and quickly. The steel truss was built using rectangular hollow section. This hollow section offer expectation static property not only in terms of buckling and torsion, but also in terms of overall member design, where they may save money when compared to open section.